Hi, my name is Nicholas Reed, and this is my video for reading week 5 lectures. The main topics we covered during this week were tension, contact forces with friction, static and dynamic equilibrium, uh, as well as some just motion from observation. So for what I knew, I knew how tension and the forces of contacts mainly worked because we have worked with it in a bit, and since we were just adding on to that slight bit of knowledge we already knew, also I've worked with it in high school, so I was pretty familiar with the tension characteristics of contact. I was also familiar with the forces for motion because it's basically undoing what we had done so far because we've been doing it from forces. It's just going in the opposite direction, and I also did that in high school as well. So I found that very easy to understand, and I didn't really have much of an issue with it. What I'd learned is a bit about the friction and how it acts in more than one direction, since it's affected in certain directions because you could be pulling at a not perfect angle, and you're always gonna need almost like a force diagram to break down how the forces affect each other and how they'd cancel out if the object was stationary, since you'd have to have a net force of 0. Another thing that was kind of a little bit more difficult was the statics and how it changes the characteristics. So like the friction, it changes as like depending on the surface and the speed it's going at. One thing I found a little bit difficult was the friction calculations and all that stuff, but after looking it over once or twice more, it was very straightforward, and I feel like I have a good understanding of it now. Um, yeah, so tension is the force that it's basically it's equivalent to a spring moving through the it's essentially a string or a wire, preferred terminology, that basically only allows tension instead of compression, so it gets pulled on, and if it was pressed, it'd collapse. So it only allows the tension from the object being pulled. So say you had a ball hanging from a string, the tension would be pointing upwards on the force. We also talked a bit about the derivative form of F net equals ma, which applies to the force of motion, using the Newton's second law to figure that out, as well as the free body diagrams to help break down the forces and their vectors in the x and y components, as well as the z components, but mainly the lecture is only focused on x and y. And with static and dynamic equilibrium, F net equals 0, and it's constantly motionless, so all the forces have to be able to cancel each other out, which makes it a little more easy to calculate what the forces are. All right, that's all I had for this week. Thank you for listening, and have a great day.